Welcome to The Explainer. Today, we're diving into a revolution that's happening right under our noses. See, it's not about the latest app or social network. It's about the very stuff our world is built from. We're going to look at how AI is literally designing the future one material at a time.
So let's just start with a big what if. Imagine you need something, let's say lighter, stronger, and way more sustainable than anything that currently exists. Now what if you could invent it, test it, and perfect it, all inside a computer, before you even make a single physical speck of it? Well, guess what? That's not science fiction anymore. It's the new reality in material science.
To really get why this is such a game changer, you have to look at how things used to be done. For, centuries, discovering new materials has been this slow, agonizing process. It was all trial and error, a lot of educated guessing, and honestly, it led to a ton of dead ends and cost millions and millions in failed experiments.
This slide just lays it out perfectly, doesn't it? On the left, you've got the old way, a long, winding road of mixing things in a lab, hoping for the best, totally limited by how much time and money you have. But on the right, you see the AI approach. It's a straight shot to discovery, and it's powered by data. We're basically leaving the physical lab behind and walking into this new age of digital design.
Okay, so how in the world does AI actually do this? Well, it all comes down to predictive power. By sifting through enormous amounts of data, AI starts to learn the fundamental rules of how materials work. It can see these tiny connections between thousands of different factors that, are just completely invisible to us. And that's what lets it predict how a new material will behave with just astonishing accuracy.
And the process, when you break it down, is actually pretty straightforward. First, you feed the AI this giant library of information on materials we already have, what they're made of, their atomic structure, how they were made, and of course, how they performed. Then, the AI model gets trained to spot all the super complex patterns in that data, and finally, once it's trained, this model can look at a totally new, hypothetical material and predict its properties with a ton of confidence.
The real engine driving this whole revolution is something called an artificial neural network. You can kind of think of it like a digital brain. It's actually inspired by our own neural pathways, and it's just brilliant at finding those super intricate patterns that connect what a material is made of to how it acts in the real world. It's basically learning the language of matter itself.
So, all that theory is great, but what does this actually look like in practice? Let's jump into some real-world examples that are already changing how entire industries work. This is the cool part.
Let's start with a really big one, making sure the things we build are strong and last a long, long time. How can we be absolutely certain our buildings or bridges are going to stand strong for generations to come?
And the applications here are just, wow, they're everywhere. AI models are predicting everything from the sheer strength of concrete in our skyscrapers to the durability of the cardboard box that your package arrives in. It's really about building resilience into every single corner of our world, from the huge and monumental to the small and everyday.
But it goes way beyond just strength. AI is also completely turning quality control on its head. It's not just about predicting if something will last. It's about spotting tiny imperfections before they can ever become a safety issue.
And the impact here is massive. AI is finding microscopic flaws in steel plates, making sure 3D printed parts are perfect, and even helping keep our food supply safe. And get this, in healthcare, it's making diagnosis more accurate by spotting cavities on X-rays that a dentist might miss, and it's even making things safer by optimizing radiation doses in CT scans.
The results are, well, they're just incredible. These AI models are hitting accuracy rates between 85 and 93% when they're predicting these critical properties. A level of precision like that completely changes the game for quality and safety.
And to put that number into context for you, this chart shows just how big of a leak we're talking about. The AI models are outperforming the old ways by 25 to 40%. That's not a small improvement. That's a whole new level of confidence for engineers and designers.
All right, so let's zoom out for a minute and think about the bigger picture. We've seen how AI is shaking up material science, but so what? What does this all really mean for our future? When you put all these pieces together, what's the ultimate takeaway? What does this incredible technological shift really lead to?
Look, what this means is that we are standing right on the edge of a new era, an era of incredibly fast innovation, where we can invent new materials in just a fraction of the time it used to take, an era of sustainability, where we can design amazing, high-performance materials out of recycled stuff, and an era of smarter, safer products that are going to improve just about every part of our lives.
And this all leads us to a final, really profound thought. For thousands of years,
Discovery has been a hands-on thing. You had to physically be in a lab, mixing things together. But we're at this amazing turning point, where the next revolutionary material, it might not come from a test tube, it might come from an algorithm. The very meaning of invention is changing right before our eyes, and we're all here to witness it.